Good evening to all. Today's our subject is hotel load and its interface with the coaches. Okay, we conduct many classes. Now we got many new J's. This will be interesting for them because they may not be knowing this concept and all. Okay, our subject is hotel load and its interface with coaches. Firstly, we will go to what is this hotel load concept and how it arises. Firstly, we will go to the coaches. Earlier, long back, different types of coaches were there, and for the coaches lighting, different methods are adapted. That are self-generation, mid-on generation, end-on generation, and head-on generation. That is for the lighting and fan, air conditioning, and other things in the coaches, we need electric supply. For that, different methods were adopted. First thing is self-generation. Old ICF made coaches, that is the blue color coaches, that you people, most of us may be aware. In those coaches, the method used is self-generation. Self-generation means they are directly provided some pulleys in the wheels, that is in the axle, and it is coupled to some generator. And while on run, through the generator, electric supply is produced, and the supply is fed to some batteries, and that is used for lighting and fan and other circuits. Olden days that was sufficient, and in that also there were two types. One is 24 volt and another is 110 volt. Long back that 24 volt supply was there due to the size of cables and its inadequacy for the our purposes. Later on in 2000 and all, it was changed to 110 volt circuit, and whatever coaches we see now are 110 volt DC supply coaches only available. Now the 24 volt self generation is completely eliminated and not available in any coaches. Now it is 110 volt self generation available in the train. Now the next is mid-on generation. This concept many may not be aware because some slow running passenger trains in some sections which are running for a very few kilometers only, in that belt and all arrangement, that is pulley arrangement, is not sufficient for charging the batteries. So they provided one generator inside the coach, that is almost exactly middle of the train, and the train length also will be very less, only 8 coaches like that, and a mid-on generation was made, and that generator operation one staff was there. That system is also not used now. It was long back used in that Diva section in Central Railway. That was the last section which used mid-on generation. Now that is also not there. Next one is end-on generation. End-on generation system is in the last coach or in the guard van or the power car, one generator is provided, and from there power supply is fed to all the coaches. Normally both ends guard van will be there. For that LSLRD coach is there. In that genset is provided. For redundancy, two gensets are there. Either they will keep one genset generator or they will keep both the gensets working. Or if any complaint is there, they will use the other end genset. Like that they used to work. That is the end-on generation or EOG. This is already available and now also actively used wherever diesel traction is there, or WAP7 with the hotel load facility loco is not there. They are using this system. In this also, previously they provided in ICF coaches, before this LHB concept, Rajdhani and Shatabdi, they have provided 415 volt genset. Long back it was used. Later on it was converted to 750 volt. At that time the 415 volt concept, the problem was for the 18 coaches, the maximum capacity was 18. In the end coaches, there was a voltage drop which caused burning of equipment or improper working of equipment. This end-on generation with the ICF coach was used for mainly for Rajdhani. Long back that orange color Rajdhani and the Shatabdi trains were having this end-on generation with the 14 volt. Now all are 750 volt three-phase AC supply fed from either EOG or HOG. HOG means head-on generation. Head is our locomotive. End-on generation, end is the last coach or the power car. Any of the system is used. Even though the HOG system is there, they can use end-on generation also in case hot load is failed en route. Otherwise, if we are not able to provide a hot load fit locomotive for that train, they will use EOG and they will work the train. In that system, 750 volt is fed from the locomotive or from the power car, and in each coach, separate transformer is provided for stepping down the supply, and they use their required supply. Normally, for AC coaches, they provide 60 kVA transformer in each coaches for their air conditioner supply. Non-AC coaches, the load is less. That is, only lighting and fan is there. Other than that, mobile charging point is there. Very less load only. So, in normal coaches, 9 kVA transformer only provided. For those who have not yet seen any transformer, you can see in road 2 and 3 in between, one 60 kVA transformer is provided for our hotel load testing. This is the concept. This is the locomotive. There are two converters, hot load A and hot load B is there. In power car, now this concept is having slight changes. There are two power cars. In both DG set A and DG set B, and control panel was there, and passenger coaches 20 or 22 coaches based on the requirement they attach, including the power car, maximum 22 coaches based on the platform length in which that train was. Up to the last coach, it is there. Now, based on the availability of healthy WP7 locomotive with hot load, they eliminated leading power car without the genset. Now they are providing. That is, only panel will be there. There won't be genset. So that we are getting additional space for passengers or freight movement or parcel van. We are getting additional space, which increases the railway revenue. End-on generation technology. In that, DG sets are there, which is the main source of the entire train load. Loads are mainly coach air conditioning and pantry car. EOG technology is used mainly in AC coaches, that is full AC coaches or AC Express and all. EOG drawbacks. End-on generation means there is a genset and it requires a diesel fuel, and continuously it will work and it will cause heavy carbon emission and noise pollution. DG set running sound causes sound pollution, which will be very difficult in some stations. We can't even speak, nothing will hear. That much sound pollution will be there. In Chennai Central and all, where the covered roof is there, it will be very difficult. Cost per unit generation of electricity by consuming diesel is very high, because diesel itself costs very high, and the maintenance is there because there is a continuous rotating equipment is there. Maintenance also required, lube oil, filter and everything maintenance, and the maintenance staff is also having continuous work in that for monitoring. DGZ maintenance cost is high. Discomfort to passengers due to the noise generated. The sound itself is 110 dB continuously. Unclean energy, use of diesel for generation leading to pollution. One more thing is there, nowadays to the Delhi area, whatever train works, it should be in head-on generation only, because the heavy pollution in the Delhi area due to the mist and all, they are facing very difficulty. At that time, if a train also comes with a DG set, that also will add the pollution. So they strictly told to work any train to Delhi with HOG only. That means the importance of hotel load working is very, very high. Now we will go to the benefits of hotel load. The benefits are pollution free. No burning of diesel, no air pollution. There is nothing to burn now. Only one electric supply source is there. That is a converter unit. There is nothing to pollute. So it is a clean energy. No pollution is there. No use of diesel alternate set means free from noise pollution. Better reliability. By reduced number of generating equipment, low maintenance, because our hotel load equipment only is there. There is no DG set, fuel tank, no fuel filling people is also not required. That and all reduces the maintenance period or breakdown period and increases the availability of the train. Reduced dead weight as compared to SG and EOG system, because the genset is not there. The unwanted weight for the generator and fuel tank and all is reduced, and that coach also we can use for additional coach. That means it is not an additional coach. We are not providing any genset. That coach also we can use for passenger transport. So additional people can travel. In regular practice, two numbers of power car equipped with EOG. After the arrival of HOG, there is need of only one power car for standby purpose. In case of any overhead equipment or OH failure is there, we have to start the genset. For that, only one HOG is available in all the trains now. The first train worked with HOG is 30277, worked with the Shatabdi on 22 to 2011. From there, we have gone a lot forward. That is, this was the first train, and after that, we faced many problems. We solved one by one, and now the reliability is very good, and almost all trains are continuously working without any problem. What is hotel load? Many may be thinking why the name hotel came. Hotel means it is feeding. Hotel load refers to the electrical power consumed by a vehicle's non-propulsion systems such as lights, air conditioning, pumps, and kitchen equipment. It's a term used in electrical engineering, particularly for trains and trucks, to describe the amenities or creature comforts that are not part of the main engine or motor that moves the vehicle. Hotel load, the word we are not mentioning for any propulsion system. Hotel load is for the load only. That is why the term hotel used in that. Everyone is telling that HOG or HLC. HOG means head-on generation and HLC means hotel load converter. That two terms are used regularly, and we are using any one term for any purpose. Both are what we mention is for the same thing only, but the two terms are having two different meanings. Hot load converter, this is again explained in detail. That is, hot load converter saves capital cost, additional revenue because of additional coaches, reduced noise, no air pollution, no thermal pollution, reduced energy cost because of there is no diesel fuel, and the hot load converter inside the locomotive so that there is no space requirement inside the LSLRD or power car or other coaches. Common interfacing with train, that is any WP7 loco can be attached to any LHB train because circuit is same only, voltage rating everything is same only. So we can attach any WP7 loco to any train. That technology used is IGBT based, so that it is a proven technology. Our loco also work with our SR also work with the IGBT technology, which is failure free design only. So we can use that without any failures. Very less maintenance only compared to the DG set. The working system. The hot load converter inside the loco is fed with a single phase 960 volt AC from loco transformer hot load winding. The output of the converter is 3-phase 750 volt AC, which is fed through IV coupler to the power car and then entire train. Control cable between loco and power car is routed through UIC coupler. Each converter is onboard two cubicle design, main converter and output contactor. This UIC, this term is Union of International Railways. That is the UIC. That term is used everywhere in vacuum brake, in mechanical, everywhere it is used. That is, it is a standard design used internationally for the any design side of the railways, and its approval is there for the whole world. That is, all railway in all the nations are registered in that, and their approved design only used for this one. That is why this UIC term is used. Main features of converter. The hot load converter converts 960 volt single phase AC to 3-phase 750 volt 50 Hz. It is a three-wire system. There is no neutral because there is no star connection. It is a IGBT based. The output only comes as 3-phase. There will be phase difference of 120 phase difference will be there, but there won't be any star point or non-neutral will be there. Whereas our IV coupler is having a neutral point that we are not connecting in loco because there is no neutral point. The hot load converter is designed to fit on WP7 type of electric locomotive. The hot load in this picture is fitted in WP7 locos. There are different makes of hot loads available: Siemens, Medha, Hyrect, Autometers, BHEL, and other makes are also coming. Different makes, whereas the concept and the specifications are the same only. Each locomotive has two such converters called A and B. So the total installed capacity of the locomotive is 1000 kVA. Each converter has two cubicles, namely main converter and output contactor. This one is the main converter unit and this one is the output contactor unit. The power to the converter is fed from the hot and load winding of the loco transformer through a contactor switched on manually by the loco driver using the switch BLHO located on the driver's desk. In this, there is a modification. Earlier, there was one more contactor available in the FB cubicle. That contactor was named as 32 contactor, which was connected from the hot and load output to one phase. This contactor was there. Its contactor output was connected to hot and load. Later on, it was decided to remove that contactor based on RDSO modification sheet. We removed from all the locos, and now it is directly connected from the transformer winding. This supply is directly connected to this hot and load unit. There are two windings in the transformer. We come to the next. This is the electrical specification. OHT supply minimum is 17.5 and maximum is 30 kV for the safe working of hot and load. And input supply is 672 1152. Based on the OHT voltage change, that input supply voltage to the hot load also will change. Input supply frequency 47 to 53 Hz. Input power factor is 0.99. At nominal voltage and full load, the power factor will be 0.99. Output parameter is 712 to 787 and the normal voltage is 750. Three-phase, three-wire system without neutral. Output voltage frequency is 47 to 53 and the standard is or nominal is 50 only. Output power rating is 500 kVA at 0.8 output power factor lagging. Output current rating is 385 amps continuous. There is a contactor in the output. Siemens series make contactor is there. Its rating is 600 amps, whereas we are giving a maximum output current of 385 amps only. This is the interface between the locomotive and the power car. This is the locomotive, and this one is cab 1 and this one is cab 2. The converter unit which is fitted just behind the locomotive cab 1 loco pilot. Here the loco pilot will be there, and this converter is called the converter number A. Converter A. It is connected to ALP side. This is having some importance because based on this connection only, the hot load on, off and all controlled from the power car. Converter A output is connected to ALP side. Here the ALP will come. Here the LP will come in the cab 2. Here the LP will come in the cab 1. Converter B is connected to LP side. From there, here the IV coupler is there. IV coupler means intervehicular coupler. IV coupler is there. IV coupler A is connected to coupler 1, B is connected to coupler 2. From there, control panel is there. Control panel A is there. Control panel common is there. In that they have split it to two parts. That is converter A panel is there. Converter B panel is there. Both they can operate from their LSLRD or power car. This is the IV coupler connection or hot load power connection. Hot load 1 output is connected to this terminal from their output contactor. Output contactor is provided backside of the LP side, just near to that hot load main unit. Hot load unit side and backside of the cab door. Once we open the cab door and go inside, you can see that hot load output contactor. That contactor is having Siemens make series contactor inside. This one is converter A and this one is for converter 2, similar design only. This is the UIC connection. UIC, we told that the UIC is there. UIC is for control supply only. From the loco 750 volt is fed to the power car. But the on and off, whether this hot load power is required for the coach or not, it is decided by the person who is operating the power car. Normally one electrical technician will be available in the power car. They are nominated by the train letting department who maintains the coach. He is only authorized to operate the contactor based on the requirement. Based on the requirement, he will turn on the switches and he can use either hot load A or hot load B for the load system, or he can use both hot load A and B for the train, full load train. In that case, if he want to give the full load from hot load A alone, he used to turn on the hot load A from the power car, and he used to operate one bridging coupler, a bridging contactor inside the power car, so that hot load A will feed full supply, both A side power supply and B side power supply in the train will be fed from the hot load converter A. Like that, he can operate hot load B alone and give the full load of the train using hot load B by operating the bridging coupler. This UIC is a 13-pin UIC unit. In that, all the pins are used. Pin number 1 is for hot load A. Output is OK. Output OK, lamp will glow in the power car if the hot load is working and everything is fine. And the pin number 2 is for output faulty indication. Pin number 3 and 4 are for resetting the power car. So resetting the hot load unit which is available in the loco. In case of any single phasing or overloading in the power car or in the train, there are chances of tripping of hot load, and the train will be in working condition, and this power car people can't reach to the loco pilot and to tell the resetting procedure, because this hot load is available inside. LP also won't go to inside, and there is no communication possible on run. So they have to reset that hot load unit from the power car. For that, in the coupler, the provision is given for the pin number 3 and 4 for converter resetting. Pin number 5 is 24-volt supply for the indication purposes in the panel and all, which is available from the power car battery. Pin number 6 is similar for hot load converter B. From the this one indication lamp in the hot load unit P, they will get one indication in the power car through the pin number 6. Pin number 7 is faulty indication in case of any fault in the converter B. Pin number 7 and 8 are for pin number 8 and 9 are for resetting hot load converter B in the locomotive. Pin number 11 is 110 volt feed from the loco battery through an MCB. 129.2 MCB is available in the loco, and its output is connected to loco hot load converter, and the same supply is connected through UIC to the power car for their operations. This pin number 11, 110 volt DC positive, and pin number 12, 110 volt DC negative is fed from the loco to the power car for turning on or the output contactor operation and all. Pin number 13 is grounded or earthed for the protection and and its shielding. That is, it is a 12 core, that is 3 into 4, that is 3 into 4 type 1 square mm cable is connected from the loco SB panel to UIC. Its shielding is earthed through the pin number 13. This is the connection in the hot load. The following indications are on the door of the converter. Normally, for all the makes, these are the indications available. Input OK, output OK, converter healthy, converter faulty, output earth fault, main contactor stuck on or off, input overcurrent, input earth fault. Normally, for all the converters, as per specification, these indications will be available in this one. This is the power car system scheme. This is only I told. From DG set, similar, from DG set they can use alternator A, contactor from the feeder. From DG set they can use this one. If they want, they can operate this one, they can open this one, and they can connect this bus coupler, and they can feed it to all the coaches. Similarly, in place of the DG set A, we have to connect a hot load A. Otherwise, in place of DG set B, we have to connect a hot load B. Otherwise, here it is mentioned, sorry. From hot load IV coupler it is there. Based on that, we can select that by operating this contactor or this contactor, they can select either DG set or hotel load. Like that, they can select based on the requirement and condition of the loco hotel load or power car equipment. This is a complex circuit of the hot load converter. This PPT I will put in the group. This is the transformer bushing. In this, two VH1 and two UH1 and two UH2 is there, and two VH1 and two VH2 is there for two hotel loads. VH1 and UH1 is connected to hotel load 1. VH2 and UH2 is connected to hotel load 2 normally. It is connected through 150 square mm 4 kV cables from the transformer bushing to the converter unit. It is directly connected. 150 square mm into 2 cables, it is provided for reliability and safety. Earlier, when WG9 was there, at that time, this hotel load concept was not there. Its capacity was less, only 6775 was there, transformer KVA. Later on, hot load was implemented, and at that time, 7475 kVA transformer was provided. At that time, the problem is there was a circulating current. As the two hotel loads were connected in parallel, there was a circulating current in the transformer winding due to unbalance in the load, because there are two AC supply fed to two different units from the same source. Due to the difference in the current, there was a circulating current inside the transformer, which also made many problems. So later on, they have provided 7775 or 7775 kVA transformer for hotel load winding. Photo is not clear. This is a hotel load front panel. Photo is not clear. This is the connection below both cab LP and ALP seat. That is, when LP and ALP sit in front, they place their foot now in that area. Back to that or under to that, there is a electrical connection, which is with the 750 volt supply to the power car. Its name is hotel load disconnecting. This junction name is hotel load disconnecting. This is IV coupler. This IV coupler is having 7 pins. Pin number 1 is there for R phase. Pin number 2 is there for Y phase. Pin number 3 is there for B phase. Pin number 4 for neutral, that we are not connecting in loco, whereas that is connected in DG set and in power car. For our side, it is not required. Pin number 5, this one is earth only, that we are connecting in loco body also. Other than that, other end also they will earth it. This one is pin number 7 and this one is pin number 10. These two are for control circuit to turn on the contactor from the power car. Control supply 4 square mm cable is connected to this one, and this supply goes to loco hotel load contactor, and when the switch is turned on from the power car, through this pin number 7 and 10, the supply will go to output contactor. Here it is mentioned. R, pin number 1, R, 2Y, 3 is B, for neutral is neutral phase is number N only. Pin number 5 is mentioned as S, and pin number 7 is contact 1 and pin number 10 is contact 2. This is the IV coupler. Firstly, we have shown another photo, same only. The control cable layout also mentioned here. This is the UIC coupler. Earlier, only one coupler was connected for power car. The another coupler was connected for MU operation, or in WG9 MU, in WAP7, earlier it was suitable for push-pull operations. Now both are modified as per railway board order. Both are parallel and both are used for hotel load only. Now there is no MU functioning in our WP7 locos, because in all our locos both are suitable for hotel load only. So we are putting a stencil that HOG like that. This is a 13-pin coupler. We have seen its wiring diagram in the previous slide. This is the IV coupler output connector. Here one link will be there. That link is for shorting the pin number 7 and 10 in the coaches. In case if they detach the IV coupler, this cover will be closed so that circuit continuity will be available for turning on the contactor. For local side, it is not required. And in case any water entry is there in that terminal, that is causing an earth fault in the control circuit. So we have removed that terminal, and there is no stagnation of water inside. How to switch on the converter? This is the procedure for switching on the converter. Switch on MCB in SB2 110 volt DC supply to the converters is fed from this MCB. Single MCB is used to switch on control power supply of both the converters A and B. Display will get on after this supply is provided. Switch on BLHO. This portion we have to tell. There is a switch in the panel BLHO. When the switch is on, there is a lamp in the panel, a panel that is LSHO. That lamp also will glow. That gives indication to the loco pilot that the hot load our side is ready, or from the loco the converter is ready and the power car staff can take the power from the locomotive. For that indication, one yellow color lamp is there in the A panel. Its name is LSHO lamp and its operating switch is BLHO. Power lights up indicating the input power to the converters is now available. This can happen only if the panda of the loco is up and also the pneumatic pressure of the loco is also sufficient. In case of insufficient pneumatic pressure, this contactor will not switch on or hold on. This is the previous case that when there is less MR pressure, there was a contactor that is 32 contactor in the FB cubicle that there one and that is pneumatically operated contactor that won't get sufficient pressure for closing that contact. So there was in the software they made a modification to close the hot load input contactor only if MR is above 6.4. Now there is no pneumatically operated contactor, so they have modified in some locos. No, that software is under trial. Software is there so that pneumatic pressure is not required for hot load converter turning on. This will give additional time saving for the power car staff because they can directly turn on before the MR is built up and they need not wait for power supply from the turning on the power supply because MR pressure is not depending for hot load on and off. The power car operator should select the converter A or converter B using switch SW1 and SW2 respectively. The power car operator should then turn on SW2. This is in the power car. Once we go and see the power car, you can see all these switches. Because in the hot load, our side operation only BLSO is there. Other than that, everything is in the power car. For the knowledge purpose, in detail, the operation is provided. In case a fault occurs in the converter, then converter faulty indication on the converter will glow and H5 and H6. The power car control panel will switch off and H3 and H4 will light up. In case temporary tripping, the converter will try to restart by itself 3 to 5 times, after which the converter will lock. The operator then has the option of pressing the reset push buttons in the power car control panel to try and restart the converter. In case the converter fails to restart by resetting, the operator now has the option of selecting DSH by operating the switch. They have to, in case the power is not coming from the loco, there are chances no. If any OH failure is there, they may not be knowing that OH failure is there because they are in the far end also, or they may not be aware whether OH is there or not at that time. They have to start the DSH for ensuring the passenger comfort. In case of temporary loss of power, when the train passes through the neutral section, power is lost to the converters and lamp S7 goes off. When the neutral section is over, power is restored. The driver must switch on BLHO switch to switch on input supply contactor manually, and then the converters will start functioning normally and without the operator's intervention. In this case, the BLHO also now made it possible that they need not restart the BLHO again after neutral section. Now it is modified that LP need not each and every time, they need not switch on the BLHO. Once it is on, that will turn on even after once tripped and reclosed. There is no requirement of again and again operation. Precautions. This is the safety instruction for the power car and all. The converter must not be operated with the front door removed. The live parts inside, this and all mainly for the power car staff only. Do not try to connect. Important is that do not try to connect or disconnect this IV coupler or UAC coupler unless the pantograph is down and the battery supply in the loco is off. there are dangerous voltages inside the coupler with respect to earth. There are cases that contract staff or railway staff who are operating the coupler, they were unaware that supply is there and they directly connected the IV coupler. So there was a JPO issued by different divisions that before connecting the IV coupler, they have to ensure that the panto is lowered. For that, one note is given to the loco pilot to instruct to lower the pantograph. And once the coupler connection is over, they will inform, and then only they will raise the pantograph and close the circuit breaker to get the air pressure. So specifications in level 1. Thank you.